average. Might be something else. Okay. How are we going to do it? How are we going to do the average? Let me clear off the median stripes because it might get in the way of your visualization.
Would you just add 13, 14, and is that 5, and then divide?
So add the 13, say that again.
Add 13, and then add 14, and then add 5.
So what's that be?
5 by
13 from
3.
27,
Or-
5 is 32.
Right.
Divide by 3 would
Yeah.
be 11-ish. So the average is 11.
Is that right?
I don't know. Why? As soon as I said 11, your eyes went like this and you looked up in the corner. Because why can't 11 be the average?
We had 11.
No, 11's over here.
Yeah.
Good. This is good. I love the fact that you went, wait a minute. As soon as you hear the result of that, you're like, that can't be right. Good. That can't be right.
7, 4, and 1.
Aha! 11, or 13, 14, and 5 are an important part of this process. But you're not going to average those, because those aren't your data. What are your data?
1, 4,
The 1, the 4, and the 7 are your data. So what I'm going to do, with your permission, rather than trying to average this right on the picture, I'm going to pull the picture back to a data table, which will be more useful for us in general. Because sometimes data will be given to you in a table. Sometimes it will come to you graphically. But both ways can be dealt with in a table. So let's pull this into a table. X is going to be your data, just like it always is. Your data in this case is 1, 4, and 7. Just like Serenity and Lawrence said. Perfect. Now, some students are going to say, cool, add 1 plus 4 plus 7 is 12, divided by 3 is 4. And you can do that. You just shouldn't. Why shouldn't you? So, a little bit louder. Tell me your name again. Emily, thank you. Emily mentions the frequency. If I add 1 plus 4 plus 7 and then divide by 3 to get 4, what am I assuming about the frequency? That they're all the same. And that's why you can do that with raw data, can't you? You can add up all the individual data points and divide by how many there are, because the assumption is all the frequencies are the same. Well, with raw data, all the frequencies are the same. The frequencies are all 1, because you're counting them all at one time. Boom! That's why the formula works so nicely for raw data. But it falls flat on its face when it's grouped. If you divide 1 plus 4 plus 7 by 3, you're assuming there's only 3 data points in your data set. And technically speaking, there are only 3 distinct ones. But that doesn't mean you can't have multiple occurrences of them. So you have to take into account, I'm going to call this an F column, so I'll give it you guys for frequency, that's pretty standard. An F column. And the 1 occurs 13 times, the 4 occurs 14 times, looks like, and 7 is that 5? That's 5, yeah. Now, some of you might look at that and go, oh, it's like a T-table from algebra classes. Perfect. Think of it just like that. Think of it just like that. It's not exactly the same. Because in a T-table in your algebra classes, generally you would plug in an X value, and then a Y value would pop out the other side. That's not what's going on here. This is simply a tally. So here's an X value. Oh, that's how many there are. So it's not really independent, dependent variables. There really is only one variable, this one right here. Just this is keeping track of how many we've got. Yes. Excellent! What can we do next?
Multiply them out,
Why would you do that, Richie?
because it's mathematics.
Because it's mathematics. Why not divide them?
What's that?
Why not divide them? Or add them or subtract them?
Well, you will afterwards.
What are you hitting at over there? He's like, multiply because it's mathematical. Something took you to multiplication.
You take that data point by your frequency.
Let's just assume that's correct for a second. X times F. Right? Symbolically. 1 times 13 would be 13, right? 4 times 14 would be
56.
56, thank you. And 35. What do those numbers even mean? What do those numbers even mean? Say that again. Rory, is that correct?
Yes.
Rory, go. How many keys? So 13 keys where? Go. Everywhere in this bar. So we're assuming there's only 13 keys in the world. Our job is to find them all. It's like a freaking Dan Brown novel. There are 13 keys in this bar. That's the assumption, yeah? There are 56 keys in this bar. And there are 35 keys in this bar. Now we know that's not 100% correct because we saw the raw data, yeah? So we know that's not exactly right, but that's what we're assuming is in there based on the results that we saw before. Here, Laura, what's bothering you?
I don't know.
What's bothering you? Tell me what's bothering you.
It just doesn't
don't have 56 keys anywhere.
Well, the thing is, the 56 keys, we didn't analyze our data set when it was raw. Let me back up a little bit. Back up here. When the data set was raw like this, we didn't break it down like this. We just added everything together. So the 56 was locked into everything else. And we're not done with Richie's math yet, I don't think. He's not done explaining his way out of this hole. So essentially, that 13, if you will, Lauren, is the sum of all of this here.
Yeah, okay.
Does that make sense?
Yeah, that makes sense.
And the 56 would be the sum of all of, I think, this to here.
Yeah.
Right? And then this would be the 35 right there.
Okay.
So yeah, we never saw it before. Good catch. Because we didn't have to see it, we skipped right over this part before. But you can't skip over that part now, because we have to account for it, and this is the only way we can. It's a way of getting back a little bit of what we lost. We lost precision, this is a way of maintaining what precision we're allowed to have. Great point though, great point. All right, Richie, you're not done yet.
Okay, add up the XF.
Everybody buy that? He's telling me to add up that column, X times F. I think that's legit going by what Lauren is saying. We now have to figure out how many keys we've got. So Rory, 13 keys, 36 keys, 35 keys. As a class, we now have this. 69.
106.
Thank you. 104, right? Yeah. Okay. From yesterday, which I don't remember from Tuesday. Today's Thursday, right? We had 106.
Yes.
You lost a couple keys, those things happen.
I don't want to brag, and I'm not going to brag because I have nothing to do with it. But remember what I told you about over and underestimating? I can't explain why, it just does. And the only explanation I have is it's too hard not to balance. It hardly ever goes exactly like that. I mean, 106 to 104, it's never that super close. But it's usually off by no more than 10 keys, which is still worth legging. It's just amazing. Now, eventually, at some class, I've been doing this 20 years and it hasn't happened yet, some class is going to come up where that adds up to 104 and the actual number is 312. It's going to happen eventually. I might retire before it happens, but it's in the pipeline somewhere. It's just a matter of will I get down that far in the pipeline before I see it. I doubt it. And we're going to see why momentarily when we answer Sweaty's question more deeply.
Well, what's the thingy?
What's the thing?
What that thingy is?
Yeah, me too.
With
The
thingy.
symbol.
Oh, this! Let me draw better so you can recognize it.
No, I still
Yeah,
don't know what it is.
Good Dennis. It means to add up. It's capital Greek sigma. It's the s sound in Greek. There's a lowercase sigma and an uppercase sigma, both of which are used in statistics. Whenever you see a big sigma like that, it means to add up. We have to add something else up too, don't we, Richard?
Column amount of,
Don't we have to add this up too? Because this is how many keys we have, but I don't care about the sum total of keys, I care about the average number of keys per student, which means I gotta know how many students I had, and I should have 32, yeah? That's 32. Now, did I, remember I forgot to put 2 data points in?
So don't we have to do 30 now?
Is it 30 or did we use 32 yesterday? We used 32. Let's just keep using 32 though. I know I screwed up the data, so there should have been 34. But since I lost those 2, let's just keep doing the wrong copy. It doesn't matter, as long as we leave the data points out. It's like those 2 people forgot to report to me. I think we're getting there. I think we're getting there, yes? Because now we can calculate the average. Now we can calculate the average based off of those 2 results. So our average over here from the group's data, and again, if you're under, some people see 2 numbers. They see the 32 and they see the 104. They go, wait a minute, what do I have to divide? Do I have to divide 32 by 104 or 104 by 32? And this will happen less and less now that assessments are out of class and you're not feeling so pressured. But just think logically, what are those numbers standing for? 32, what? Students, the amount of students. 104 keys. So keys per student, exactly. Sarah, yes, keys per student, not student per keys. Keys per student, so you gotta divide keys by students. So it's gonna be 104 out of 32, which is gonna give me, let's see, 3 of those would be 96.
3.25.
Say that again? 3.25! We'll call it 3.3. Look, oh, no, 3.3. It was only off by 2 keys out of 104, 106. Hardly any error whatsoever. I'm happy. So the moral of the story essentially is you can still pull meaningful data even though you have to sacrifice precision. Now, some of you are not going to be convinced by this because you're like, oh, we got lucky because it was our data set. No, I think you went home and messed with it, so it worked out better. But I didn't. I don't have to. It works out itself. Now, you'd probably be more convinced if you saw more data. Well, that's good. The last class, I could report back to you their data. But rather than reporting back to you their data, I want to answer Sergey's question with a more thorough explanation. So check this out. I'm going to pull this screen down. I'm going to show you something I built for you a couple weeks ago. I had this idea right at work one day. I'm surprised I don't die riding to work. Think about math all the time. But ask me that question.
Don't say that.
Well, it's just sometimes I think about it. I'm always like thinking about math and stat, and somehow I go straight on the road.